Before we get into 7-1, which is solving equations with variables on each side, let me give you a little bit of a preview of just Chapter 7. Chapter 7 is on equations and inequalities, and if you said, well, we've done that already, you'd be right. We looked at equations and inequalities earlier this year, and there's not too much new here. In 7.1 and 7.2, we'll look at more equations with variables on both sides and also with grouping symbols, and so we mean parentheses here, right? But we've looked at equations with parentheses before. And then 7.3 through 7.6, there's just 6 sections in this chapter, are all about inequalities, right? So 7.3 will be about writing inequalities. 7.4 will be about solving inequalities through addition and subtraction. As you might imagine, 7.5 will then be about solving inequalities through multiplication and division, and 7-6 will be about multi-step inequalities, so we'll be back to the land of shoes and socks and what that looks like for inequalities. What all of this has in common is we're still in the world of one variable, right? So we're still going to be solving for, let's say, x as opposed to x and y. And then when we get to an inequality, right, if we are still in the world of one variable, we'll be able to graph our solution on some sort of number line, right? So it's just a more complicated version of some things we've done earlier in the year. But let's now get into solving equations with variables on each side. You'll see this is not so bad at all. All right, so as I said, this is, sorry for the double noise here. As I said, this is one basic rule, which is using the addition or subtraction property of equality to remove the variable from one side. So again, the first thing that you want to do is use addition or subtraction. And remember, we mean the property of equality, so do it to both sides, okay? Sorry about that. Use the addition or subtraction property of equality to remove the variable from one side. So that's easier to show what that looks like with an actual equation. So notice we have the equation 2x plus 3 equals 3x, and why is this different from what we've seen? Well, we see that x appears on both sides of the equation. So the first thing that we really want to do here is take away 2x, and that leaves me with 3 equals x. Oh, we're done. What if we had done that a different way? 2x plus 3 equals 3x. What if we had decided, what if we had decided instead to take away 3x from both sides, minus 3x, sorry, let me switch to blue here, minus 3x. Well, 2x minus 3x is negative 1x plus 3 equals 3x minus 3x is 0. We just have shoes and socks here. We can take away 3, and get negative 1x equals negative 3. Divide by negative 1, divide by negative 1, and still get x equals 3. This way over here was shorter, so you want to kind of look out for that, but this way would have worked as well. Let's look at another one. 5x plus 4 equals 3x minus 2. Again, we see that we have the variable on both sides of the equation, so we'll use addition and subtraction first to get rid of the variable from one of the two sides. Now, I think it makes sense to keep a positive coefficient, so instead of subtracting 5x, why don't we subtract 3x? Now, notice what's going to happen here if we didn't change this to adding the opposite, right? We might misrepresent what we have on this side. So let's see, 5x minus, on the left, 5x minus 3x is in fact 2x plus 4 equals, we've gotten rid of the variable over here, 3x minus 3x is 0, and we're left with negative 2. Hopefully we can see that because we've changed subtraction to adding the opposite. At this point, where it's shoes and socks, this should be a home run for you. Minus 4, 2x equals negative 6. This is chapter 2. Don't mess this up. Okay, divided by 2, divided by 2, x equals negative 3. We have solved for the variable. We have found the value for the variable that makes the equation true. If we were to go back and plug it in, we'd have to plug it in there and we'd have to plug it in here. And what you'd find is that the equation would be true. And just to show you what that looks like, 5 times negative 3 plus 4 equals 3 times negative 3 minus 2. Okay, that's negative 15 plus 4 is negative 11, and that's negative 9 minus 2 is negative 11. So that works. Okay, as is the case with any of this, the way that we make it more challenging is to introduce word problems. So here's a word problem. This one is from your book, and therefore it is dated. Let me read it to you. A video store has 2 membership plans. So believe it or not, back in the day, we would actually go to stores to rent videos. We didn't have Netflix, which just delivered things on demand. We had to do a little planning, a little shopping. So a video store has 2 membership plans. Under Plan A yearly membership costs $30. So that is a fixed cost. You just pay it annually. And then it would charge you $1.50 for each movie that you rented. Okay, under Plan B, the annual membership costs $12, so less for your annual fee, right? Plus $3 for each movie that you rented. What is the number of rentals? What number of rentals results in the same annual cost? So there's a lot to do here. Or a lot to think about, and I will tell you that setting up the equation is far more challenging than solving the equation, in my opinion. But the clue here is we're looking for the number of rentals. So why don't we start by actually defining a variable? Let x equal number of rentals. Now, don't make the mistake of thinking because we have 2 plans, we want 2 variables. We don't. Okay, so if we think about the cost of, if we think about the cost of Plan A, right, the cost of Plan A is $30, that is a fixed cost, right, plus $1.50 for every rental, so that would be plus 1.5x, okay? Why 1.5x? Well, if we rented 1 movie, it would cost $1.50. If we rented 10 movies, it would cost $15. Okay, you get the idea. Plan B, right, says that the annual membership costs $12. Again, that's a fixed cost. We have to pay whether we use it or not. And $3 for each rental. So that would be plus 3 times x, right? $3 times the number of rentals. Okay, then it says what number of rentals results in the same annual cost. Well, that would mean that Plan A would equal Plan B. So that must mean that these 2 expressions would also be equal. Well, that, the equality of 2 expressions, can give us an equation. So 30 plus 1.5x equals 12 plus 3x. You should see by now that we have sort of the classic variable on both sides of the equation. Remember our strategy, which is to say we want to first use addition or subtraction to get rid of the variable from one side. I see a variable here and a variable here. I'm going to subtract 1.5x because I like positive coefficients, and that leaves me with 30 equals 12 plus 1.5x. We're in classic shoes and socks mode, minus 12 minus 12. That seems to be 18 equals 1.5x. Right, we're now going to simply divide by 1.5 and divide by 1.5, and that is going to give me 12 equals x. Okay, now let's take a moment to think about what that actually means. Like X was the number of rentals, right? So that means if we rent 12 movies, right, plan A is going to cost the same as plan B. Let's check that out. For plan A, right, we're paying $30 plus, right, $1.50 per movie times 12 movies is $18. So we're going to end up paying $48 in plan A. And for plan B, we're paying $12, but we're paying $3 per movie, and we've got 12 movies, so that's 36 is 48, so there you go. You should think about if you rent more than 12, which plan would be more expensive, and if you rent less than 12, which plan is more expensive, and we'll talk about that during class. So that is 7-1, solving equations with variables on each side, and a little bit about word problems.